All right. This chapter, we have been talking about a process. We've been building up to a process called solving right triangles. And we're going to do that properly next week. And the idea behind that is that we are going to solve for specific sides and angles in the triangle. So our goal is to solve for every side and every angle in the triangle. So I'm going to talk about what we've done so far and what we're about to do. So far we have two tools to solve for different sides in our triangle. And today we're going to learn about the third. The two tools that we have so far are Pythagorean theorem. That's when we know two of the sides and we set up c squared equals a squared plus b squared to solve for the other side. And then the other is if we have 30, 60, 90 or 45, 45, 90 triangles, we have a specific pattern that those follow. The thing we're going to talk about today is that is not just because of an angle being 30 degrees or 45 degrees. Every single other angle measure has patterns associated with it. But they don't come up as much, and they aren't as easy of patterns to memorize, so we don't memorize the pattern for 48, 42, 90 triangles. Okay? Instead, we're going to use a concept called trigonometry. And the idea behind trigonometry is that we have an angle here, and you'll see this come up once or twice. An angle here called this is a Greek letter that we use as a variable for angles sometimes called theta. And it's used to, sometimes you'll see it in problems to stand for angles that we don't know. So sometimes you'll see, X and Y and Z to stand for sides that we don't know, and then Greek letters to stand for angles that we don't know. That happens sometimes in this topic that we are talking about of trigonometry. So here is the idea. Is that once we know what that angle is, the sides are going to all have a relationship to that angle. It's the idea that I talked about when we talked about how to memorize the 30, 60, 90 pattern. One of the things that we said is across from the smaller angle is the shorter leg. And across from the larger angle, the 60, was the longer leg. And so part of the idea is that the larger the angle, the longer the side across from it. And the smaller the angle, the shorter the side across from it. And so that's part of what we're going to talk about. I'm setting up some of the ideas so that the slide with the big dump of information doesn't just feel like a big dump of information. We're going to set it up. So we're going to have we're going to have three different sides in this triangle, and instead of we're going to call those sides in relation to this angle. So our three different sides are the side that's across from this angle, and we talked about how to get that when we did our hypotenuse being across from the right angle, or talking about going across from the 30 was our short leg. We have the side across from whatever angle we're talking about. And we're going to call that side our opposite. Our opposite is our side that's across from the angle that we're talking about. That's our opposite leg. We also know the name of this side because it's across from the right angle. That's our hypotenuse. So we're going to call it the hypotenuse. So between the two legs, we have our side across from it, which is our opposite, and then our other leg is touching the angle right here. So it is right next to that angle. So we're going to call it by a word that we've been using to say that something is right next to something else, and that is adjacent. That the angle and the side here are touching. So this is the leg that's adjacent to my angle, and this is my leg that's opposite the angle. Now I'm going to abbreviate these in just a second here. So what we have is that once we know our angle, we can compare pairs of sides in relation to that angle. That's what we're going to be doing. Is we're going to narrow down what pair of sides are we interested in using. And there are three different pairs of sides that we could be talking about. I could talk about these two sides, and these two sides. Watch that happen again. Watch up here. My three different pairs of sides I could talk about. First pair of sides, second pair of sides, third pair of sides. So these two, these two, these two. And we're going to call each of those by different names. Those different ratios are going to go by different names. So if I'm comparing the opposite with the hypotenuse, if I'm comparing the opposite and the hypotenuse with each other, that's going to be called sine. It's spelled S-I-N-E. And each of these are going to be abbreviated with the first three letters. So sine is going to be abbreviated like this. You'll see it that way in your calculator as well. So that is abbreviated short for sine. So it is pronounced sine and not sin. So comparing this pair of sides is talking about the sine of the angle. Pair of sides number two is I could compare my adjacent with my hypotenuse. It's pair of sides number two that I can compare. And that's going to be called the cosine of the angle. And we're going to abbreviate it COS. And we're going to call it cosine. So we've done pair of sides number one, pair of sides number two. Here's pair of sides number three that we could talk about, which is the opposite and the adjacent. And that's going to be called the tangent. And again, first three letters is what we're going to use to abbreviate. So you're going to see it called TAN. Abbreviated TAN. And so zooming out, big picture, what are we going to use these for? In solving our triangles, what we're using these for is that we're going to have, it's going to be used to jump from angles to sides. And so the way we're going to start using them tomorrow, the type of equations that we're going to solve tomorrow, when we look at these examples, are going to be, we're going to use an angle that we know to solve for a side that we don't. So I'll say that again, because that's the big picture of what we're going to be doing. Trig is going to allow us to jump from talking about from sides to angles, or the other way around, to using angles to solve for sides. And so that's what we're going to be doing. We're going to be using angles that we know to solve for sides that we don't know. So we'll look more at that tomorrow. But for today, I just want us familiar with these three terms and their definitions and how to set them up. So that's what we're going to focus on today. And I wrote these with a slash to talk about these two. I did that on purpose because these are going to end up being fractions. And they're going to end up being in this order, O over H. So that's what you're about to write down here, is how these fractions get written. Here's the big slide chock full of information. So in the blanks at the top here, when it says trigonometric ratio, you're going to write down all this. Then, right underneath it, it's going to have a place for sine of A, cosine of A, and tangent of A. And in those spots, you're going to write down sine of A. You just need to write down the highlighted words. So for sine of A, you're going to write the fraction of opposite over hypotenuse. The highlighted words are what you're going to write down. For cosine of A, you're going to write down adjacent over hypotenuse. For tangent, you're going to write down opposite over adjacent. So I will give you a moment to write. Now, the structure of how these are going to look is that you're going to write whichever trig ratio you're looking at, so sine, cosine, or tangent. And then sometimes you'll see me write it in parentheses. You're going to put whatever the angle is that we're talking about. So sometimes a number will go here if we know what the angle measure is. So that's going to happen a lot tomorrow. There'll be a number here, and that's going to be the angle. And then we're going to put equals, and then we're going to put whatever fraction we have. So in the case of sine, we're going to put sine, and then our angle, whatever our angle is, equals, and then we're going to put the opposite on top of the fraction. We're going to put the hypotenuse on the bottom of the fraction. It's important to say which angle we're talking about, because you'll see this in a second. Across from angle A, my opposite for angle A would be different if I were talking about angle B. Across from angle B would be this blue side, A to C, if I'm talking about angle B. So the side across from angle A and the side across from angle B are different sides. So now let's look at some examples to show what this setup is going to look like. Here we go. Find the sine, cosine, and tangent ratios of angles J and K. So we're going to start with angle J and get our three ratios for all of them. We're going to write the ratios in fraction form, and then we're going to reduce them. So we're changing from what the directions say, because I want to just keep it to fractions and not have to write out big, long decimals. So we're starting with angle J. Here's angle J. And the first thing I'm going to do is I'm going to use angle J and say, where's my opposite, where's my adjacent, where's my hypotenuse? So first off, my hypotenuse across from the right angle, bam, right there. Then I need to figure out which one's my opposite and which one's my adjacent. If I'm standing at angle J, my side across from that angle, my opposite, I'm standing at the angle, I look across, and what do I see? I see this side, K to L. That's my opposite. I'm going to label it with an O. That leaves my adjacent, which is touching angle J, my leg that's touching angle J, to be J to L. So that's my opposite, my adjacent, and my hypotenuse. So now we're going to write out those ratios. Remember, I talked about how these are going to be written. We're going to start with the sine. So we're going to write the three-letter abbreviation, SIN, of the angle. So the angle we're talking about is J. And then for these first couple, I'm going to remind you of what the ratio is. Sine is going to be opposite over hypotenuse. So now we're going to plug in what the numbers are. Opposite across from J is 24. Hypotenuse is 40. And then I'm going to reduce these fractions. In all of these cases, you're going to be able to reduce them by dividing them all by 8. These are all divisible by 8. So if I divide all these by 8, 24 divided by 8 is 3. 40 divided by 8 is 5. 3 over 5. That's sine of J. Now we're going to do cosine. We're going to do the same thing. Cosine. We're going to put the angle that we're talking about, which is J, equals. My ratio says that cosine is going to be adjacent over hypotenuse. And this fraction has to be in this order. Adjacent has to go on top. Hypotenuse has to go on the bottom. Otherwise, it's not cosine. So adjacent goes on top. That's the 32 going on top. 40 goes on the bottom. (32 over 40). These are both divisible by 8 again. 32 divided by 8 is 4. 4 divided by 8 is 5. 4 over 5. Finally, tangent. Tangent of our angle, which is J, equals opposite over adjacent. Again, opposite goes on top, adjacent goes on the bottom. So opposite's going on top, that's 24. Adjacent goes on the bottom, that's going to be 32. Which equals 24 over 32. Those are both divisible by 8. 3 on top, 4 on the bottom. 3 over 4. So this gives me a ratio. Whatever this angle measure J is, I don't know what it is in this case, but it's saying that whenever an angle measures this amount, here's the ratios of my sides. Anytime an angle measures that amount. So anytime J has this measurement, the opposite is 3/5 the size of the hypotenuse every time. And then same for the relationship between the adjacent and the hypotenuse. So it gives me a ratio that we can use to solve for the side anytime we know what the angle is. That's what we're going to do tomorrow. But let's focus today on getting us comfortable with writing out these ratios. So we're going to do the same thing, but this time we're going to use angle K. It's going to be very, very close to the same thing. There's going to be one small difference here. Now we're talking about angle K. And when we talk about angle K, this is still the hypotenuse. But then my opposite and adjacent are going to change. So watch closely. I'm standing at angle K. I look across from that angle. Across from that angle is going to be my side opposite it, J to L. So now my side across from angle K is going to be J to L. So 32 is now my opposite. Another way you can catch where your opposite is, by the way, is that you can say that the side across from angle K shouldn't involve K when we're talking about the side length. So if we're talking about across from angle K, it's going to be the two letters that don't involve K. That's J and L. J to L is my opposite. And then this side, K to L, is now touching angle K, so it's my adjacent. So again, it matters which angle you're talking about. That's why over here I put the sine of J, cosine of J, and tangent of J. And why over here I'm going to put the sine of K, cosine of K, and tangent of K. Because it matters which angle you're talking about. Now that I'm talking about angle K, my opposite and adjacent swapped places. They were in different spots. So let's start with sine. Sine is still opposite over hypotenuse. So I'm going to do this a little bit quicker this time. Opposite over hypotenuse. Opposite across from angle K was 32. Hypotenuse is still 40. They're still both divisible by 8, so that's going to be 4 over 5. Cosine is adjacent over hypotenuse. Again, it has to be in this order. Adjacent has to go on top, hypotenuse has to go on the bottom. Otherwise, it's not cosine. Adjacent to K is now my 24. Hypotenuse is still 40. Both divisible by 8, it's 3 over 5. Tangent is opposite over adjacent. For K, opposite of angle K is going to be J to L. My adjacent is going to be 24. So now instead of 3 over 4, since opposite and adjacent switched places, the fraction from J to K flipped, and now it's going to be 4 over 3, both divisible by 8. Any questions on that? All right, take a couple minutes, and I want you to try the next one. You're going to do the exact same thing with angle J and angle K and get all 6 of those ratios. But now we're doing it with a new triangle. On this one, the numbers are smaller, so reducing the fraction should be easier than it was on this one. The fractions are going to be divisible by 2. That's how you're going to reduce them.